Alright, we're going to take a look at graphing nonlinear inequalities. Graph the solution set to each nonlinear inequality. So we're going to take a look at this. This is in what some books call vertex form. And when we have it in vertex form, basically the minus belongs to the formula here. And this is a lot of times on this other side as a minus, and so the minus belong to the formula. So my vertex in this one is actually this right here, the the coordinate point 1, 3. So there's my point that I'm going to graph over 1 up 3. And now I can't know the y-intercept with these parentheses here, so if I go ahead and multiply out that, if I FOIL that binomial and then add it to the 3, my y-intercept I can tell is 4. Okay, so there's my vertex, and I know that my y-intercept is 4, and so I get kind of an idea of what the graph looks like. It's doing this. So that's good enough for me for right now. We are supposed to have that actually a smooth curve, so please make sure that yours is a smooth curve, no points on a parabola, no pointy points on a parabola. So let's go ahead and now take a look at how we would shade this. We know that it is a solid boundary. I'm not going to say a line because it's a boundary, because it has the or equal to, less than or equal to. Okay, so some people think that the shading on a nonlinear inequality is a little less intuitive than with than with linear inequalities. So what I'm going to recommend is just what I did in the last video, and that is to just do a test point. So let's pick a test point. I'm going to pick the point 0, 0. As usual, I'm going to put that in the inequality. Pardon me, there's supposed to be a 0 there. There's 0. I'm going to go 0 minus 1, all that squared, plus 3, and I'm going to ask myself, is this a true or false statement? So 0 minus 1 is -1, squared is 1 plus 3. Is 0 less than or equal to 4? That's a true statement. That just means that this point 0, 0 is on the correct side, the true side of this parabola. So that means the boundary is separating the true from the false side. And so I'm going to shade everything that's outside of it like this. Okay? And of course the parabola goes up forever and ever, and so does the shading as it stays on the outside of the boundary. So those are all of the solutions, the coordinate pairs. They're an infinite number. Okay, that makes up the whole solution set. Let's take a look at this one. Believe it or not, this is the same parabola, but I wanted to remind you that if you don't see it in vertex form or something close to that, you can always use this. You can always use the vertex, get the vertex this way. Remember that the x-coordinate of a vertex is -b over 2a, right? And we know that this is my a, this is my b, and this is my c, right, of this quadratic. And so I'm just going to go ahead and get the vertex this way. So I have that -2 over 2 times 1, and we get 2 over 2, which is 1. So I get my vertex is 1, and we of course saw that in the last example. We already know the vertex is 1, 3. So now let's take the 1 and put it back in and calculate the y value. And of course when we're doing this we're pretending it's an equals. So we have y is equal to 1 minus 2 plus 4. So we have y is equal to -1 plus 4, and we get y is 3, and that's my y coordinate of the vertex. So again, there's my over 1 up 3. My y-intercept, because there are no parentheses, that is the y-intercept, which is a 4, and of course here's my parabola. It's probably a little bit too narrow there, but okay, so this is less than or equal to. Let's look at what this one was. This one was less than or equal to. So we know, of course, that the shading is going to be, well, let's try that again. We know that the shading is going to be out here. So if you're unsure about the shading, just make yourself a test point. All right? It's not that, doesn't take that long. Okay, let's go on to the next one. And the next one should look familiar to you. It's a circle. It's a circle, right? We know that the standard form of a circle is x squared plus y squared and then equals the radius squared. So let me get a little bit of information here. R squared is the 9, that's that, so that makes my R 3. And my center, because there's nothing being added or subtracted here, my center is at 0, 0, the center of the circle. Alright, we're ready to put this on the coordinate plane. 0, 0 is my center. I'm going to go out 3 in every direction. Looks like my graph paper here is a little bit oblong, but we'll just go with it. It's a little bit wider than it is tall. There's my circle. Now, I went ahead and made it solid. This is a solid line because it's or equal to. Now, greater than, okay, I have the circle greater than. You can think of that as the radius, greater than the radius. So it makes sense to me, this intuitively, that this would be shaded outside. But let's just go ahead and take a test point. Okay, so I'm going to take a test point. I'm not going to use the point, well, I guess I could use the point 0, 0 because it's within, it's not on the boundary, right? It's within the, it's on one side or the other of the boundary, which is a circle. So let's go ahead and put it in. We've got 0 squared plus 0 squared. And is that greater than or equal to 9? Question mark. So 0 is greater than or equal to 9? Question mark. Heavens no, it's not greater than or equal to 9. So I know that the inside of the circle is not the solution set, so I know that the outside is. And so I'm going to I'm going to color in the outside of the circle. Pretty simple, right? Oops. There we go. It's nice if you have a highlighter. It's a little quicker. Okay, good enough for that. Let's move to the last one. This one's probably the most difficult kind that we do, just because we have to transform it into another form, which means that I'm going to change it into exponential form. So I have 3 to the y power is equal to x. Now I'm going to quickly make a little table to get my shape. And remember, when we're graphing logs, we go backwards. So I'm going to pick the y first. 3 to the 0 is 1. I'm going to go with I'm going to go to -1, and that's a third. And I'm going to go with -2, and that's a ninth. Now I'm going to go forwards. 3 to the 1 power is 3, and 2 power is 9. So let's go ahead and put these points on. Okay, let's see here. I have over a ninth, -2. Okay, that's a really tiny, whoa, come back here. That's a really tiny spot down there. I have over a third, -1. I have over 1, up or down 0, there's that. I have over 3, up 1. And I have over 9, up 2. Now, that does look like a log. It is a dashed line, right? So I'm going to connect that with a smooth curve, but a dashed curve. And it's never going to approach that vertical asymptote, is it? You remember that logs are never going to, they don't have a 0 in their domain, nor do they have negatives, right? So nothing over here is going to be in the domain of that thing. If you look at it just this way, it's real obvious. What is the domain of this thing? I could never even get a 0 if I wanted to. My 0 can be on the y side, but it can't be on the x side, because a 0 doesn't produce a 0, a negative doesn't produce a 0, nor does a positive produce a 0. So we know that that's correct there. Now, let's take a look at what in the world, which side of that thing should we shade? Well, let's take a test point. Okay, I'm still going to take a test point, even on the logarithm kind. And I'm going to pick the point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope, I'm going to pick the point 3. Try to make it a nice one here. I'm going to pick the point 3, 1. Yeah, let's do it. 3, 1. Okay, pardon me, silly me. I can't use 3, 1 because it's actually on the boundary itself, right? So I'm going to go with 3, 2. No problem. All right, so the reason I picked 3, 2 is this. Think about it. I'm going to go back to this original problem. Watch this. 2 is less than log base 3 of 3. Now, think about it. What is log base 3 of 3? Well, if I set that equal to some random thing and I'm just trying to figure out what it is, it's 3 to the x is equal to 3. Well, that's a 1, x is 1. So this whole thing is actually equal to 1 whole. It's 1. So then this is the number 1. So then I'm going to check my inequality. Is 2 less than 1? False. It's not less than 1. So I know that this point right here is not going to make that thing true. So the point over 3 up to this point right there is on the wrong side. It's not on the true side, it's on the false side. So now I'm going to take my highlighter and I'm going to shade below it. Okay, so it's a little harder to figure out which side to shade. I mean, it does look like that's below, but some people just have a hard time with that, thinking that that's intuitive. So let me do it. I tell you what I'm going to do. I'm going to do another test point. Let's just make sure you understand what's going on here. Let's say I'm going to do the test point. I'm going to keep the x a 3. Let's do the test point 3, 10. Oh, let's do this. Let's do the test point 3, negative 5. Okay, so here we go. I have negative 5, and I have this log base 3 of 3. All right, I've put that in for the y, and I've put this in for the x. Well, I know that when I have a log with a base and an argument matching, that's the number 1. So then I ask myself, is that a true statement? Is negative 5 less than 1? Sure it is. So the point over 3, negative 5, 1, 2, 3, 4, 5, that indeed checks out. That does tell me that that is the true side of that, of that log. Okie doke. Hope this was helpful. Thanks for watching.